Good. Calculate the area of minor segments where the radius of the circle is 14 centimeter. The theta is subtends, that's the angle is subtends, is 180 degrees. Now to calculate the area of minor segment is equal to area of sector minus area of triangle. So the area of sector is going to be theta over 360 times pi arrow square minus 1 over 2 arrow square sine theta. What's theta here? 180 degrees. 180 over 360 times 22 over 7 times arrow, which is 14 times 14 arrow square, minus 1 over 2 times 14 times 14 times sine 180. So 180 here 1, 180 here 2, 7 here 1, 7 here 2. So what we have left is 22 times 2. Okay, so we still have 2 here 1, 2 here 1. Okay, so we have 22 times 14 minus 2 here 1, 2 here 2, 2 here 7. So we have, what we have is 84 times sine 180. So to get the area of minor segments, this is what we are going to do now. Just give me a sec. Let me quickly check this with my calculator. If you observe very well now, theta is 180 times 22 over 7 times 14 times 14, and this gave us in total 22 times 14. Now 1 over 2 times 14 times 14 times sine 180. Now 2 here 1, 2 into 14 is 7. So 7 times 14 is 84. 84 times sine 180. Now if you check sine 180 in the calculator, it will give us 0, because if you remember our sine curve, it says sine 0 is 0, sine 90 is 1, sine 180 is 0. So that's why we have 0 here. So 84 times 0 is going to give us 84. Going to give us 0. So this place is already 0. So from what we have here now, it's only here we are going to work with. 22 times 14 give us 308 centimeters square. And that's how we got our area of minor segment. But how do we get our area of major segments? Now this is our circle. Now if this is our circle, this is our major segment, our minor segment. This one you are seeing as our minor segment. Our major segment is this part here. So to get the area of the major segment, we are going to say area of circle minus area of minor segment. Area of circle minus area of minor segment. So the area of the circle now is going to be pi arrow square. Pi arrow square minus 308 centimeters square. Pi arrow square, which is 3.142 times 14 square. And in total, I think this gave us 615.832 minus 308. So let's subtract it. 15.832 minus 308. Okay, this gave us 238 0, and this gave us 7 0 307 points. Okay, so we're having 307.832 as our answer. Okay, so for the length of arc in that same question, a length of arc is equal to theta over 360 times 2 pi r. And theta we have there is 180. 360 times 2 times 22 over 7 times r, which is 14. 7 here 1, 7 here 2, 2 here 1, 2 here 180, 180 here 1, 180 here 1. So what we have here, length is equal to 44 centimeters. So the length of the arc is 44 centimeters. Now we're also told to find the area of sector. Okay, so for the area of sector, I believe we've already done this before anyway. The area of sector is going to give us theta over 360 times pi r square, which is 180 over 360 times 22 over 7 times 14 times 14. So let's check. 180 here 1, 180 here 2, 2 here 1, 2 here 11, 7 here 1, 7 here 2. So what we have here is 22 times 14. And I think if we check here, it gave us 308 centimeters square, area of sector. Then we also have perimeter of sector. perimeter of segment is going to give us the length of the chord, that's this part, then the length of the arc. So this is going to give us 2r sine theta over 2 plus theta over 360 times 2 pi r. So what's the length of the chord now? That's here. So we're going to find the length of the chord now, 2r. So it was r 14 sine theta over 2. Okay, so that's sine 180, that's sine 90 plus theta over 360, that's 180 over 360 times 2 times 20 over 7 times 14. 7 here 1, 7 here 2. 180 here 1, 180 here 2, 2 here 1, 2 here 2 here 1. Okay, so what we have here is 44 plus. Now if you check here, sine 0 is 0, sine 90 is 1. So sine 90 here is 1. So what we have here is 1 times 28. This will give us 28 plus 44. 44 plus 28 will give us 72. So that means our perimeter of segment is going to give us 72 centimeter. Remember that the unit of perimeter is what? Centimeter. Perimeter of segment is centimeter. Then when it comes to length of perimeter of sector, the formula is going to be, you see this place is a radius, this place is a radius, radius, then this place is a length of arc. So it's going to give us 2 arrow, because we have 2 arrow here. Perimeter is the length around the shape, then this place is the length of an arc, which is plus L. 2 arrow plus theta over 360 times 2 pi arrow. This will give us 2 arrow, 2 times 14 plus over 360 times 2 times 20 over 7 times 14. 7 here 1, 7 here 2, 180 here 1, 180 here 2, 2 here 1, 2 here 1. So what you have here now is 44 plus 28, and this will give you 72 centimeter. So perimeter of the segment now is indirectly equal to the perimeter of the sector at some point. So 2 arrow plus L, which is 2 arrow plus theta over 360 times 2 pi arrow and all that, and that's how we got 72 centimeter. Now remember, we can also find the length of chord, and length of chord is equal to 2 arrow sine theta over 2. So it depends on your value of theta. In this place now we have radius with 14, sine 180 divided by 2, which is 90, and sine 90 is 1. 14 times 2, which is 28. 28 times 1, which is what? 28. Then so our length of chord now is going to be what? 28 centimeter. Take note that length of chord is not centimeter square, but rather it is what? Centimeter. So what are the various formulas? The first one, we have the length of arc, which is theta over 360 times 2 pi arrow. Then we have the perimeter of sector, which is 2 arrow plus L, which is 2 arrow plus theta over 360 times 2 pi arrow. Then we have perimeter of segment, which is equal to 2 arrow sine theta over 2 plus theta over 360 times 2. Perimeter of segment, we also have area of sector. Area of sector is equal to theta over 360 times pi arrow square. We have area of segment, but the area of segment can be divided into minor and major segments, which is theta over 360 times pi arrow square minus 1 over 2 arrow square sine theta. Now these minor segments now is the area of sector minus area of triangle. So area of sector and area of what? Triangle. That's why it gave us theta over 360 times pi r square minus theta minus 1 over 2 r square sine theta. Then the area of major segment, area of major segment is equal to area of circle minus area of minor segment. So this is going to give us pi r square minus area of what? Minor segment. Then we also have length of chord. Length of chord is equal to 2r sine theta over 2. 2r sine theta over 2. So let's just go through it again. Length of an arc, theta over 360 times 2 pi r. Perimeter of sector, 2r plus L. 2r plus theta over 360 times 2 pi r. Perimeter of segment, 2r sine theta over 2 plus theta over 360 times 2 pi r. Area of sector, theta over 360 times pi r square. Area of minor segment, theta over 360 times pi r square minus 1 over 2r square sine theta. Then we have the area of major. Now, apart from